Andrey Borodin, Yandex, do it yourself.
Andrey Borodin from Yandex. Let's wait for 3 more minutes and then... Yes, let's wait.
Вдруг кто-то хотел именно на вступление.
Да, конечно, конечно.
Давайте тогда потихоньку начнем. Да. Меня зовут Андрей Бородин, я разработчик в Яндекс.Облаке.
Andrey Borodin, I'm the developer in Yandex Cloud. So I do some Postgres development at work, and sometimes I do some work at home. So today we have a presentation on what you can do by yourself in the evenings. So this index do-it-yourself belongs to Postgres. There is a serious presentation of Alexander Korotkov, who's the author of this technology of index expansion, and you can find this on YouTube. And this is more serious, and my presentation is more on how to change some lines. And some of the technologies at PG_AM as methods of access. And the main idea is that we have index scan, which should identify the data in the heap. It can be found through the layer of operators, and in this area, in this place, the Postgres can be extended, and you can use different methods on how to find the data in relative base. And if you write some methods on how to make a search, it gets all the guarantees as the database management system, and it works in isolated transactions according to the levels of isolation. And in general, it receives all the infrastructure, but you need to write just a couple of lines of the code. So in order to create your index, you need to have an idea of how you're going to search. The generalized index search, this is the idea that you're looking for something throughout the whole general description. So this data grouped by the some person, not generalized. And there is in generalized. When you're looking for something partially, like a piece of the wheel, you're looking for the cars with that type of wheel. So you have an idea and you want to realize this idea, implement this idea. So you need to create the extension, the wrapping of what can be imported into cluster. Then you need to specify index handler that can specify on how to search. Then you need to look for the data and to give a name. You need to write the vacuum. If you want to see your index on the replicas, you need to implement val log, which means that you need to write a lot of things. But there is a more simplified way, and you can take the existing index, copy it, and make it more complex or make it more simple. So I want to suggest the following. Let's see how we can do that. I have terminal here. We can please zoom in. I have Postgres initial codes, some fresh versions from Peter Eisentraut, January. Then we go to the folder contrib, cd contrib, and then create the index, which will be called IDIY. For us to take the existing index, we can forward gist. So we go to the initial source of Postgres, CRC, backend, access, gist, and we'll take the whole C code, just like that. And we also will take some header files. will put it in the folder access, or the file access.
Так, нам понадобится еще control
Then we
file,
need
make
control
file.
file,
Мне
make
зачем
file.
использовать
We'll
extension?
take it from other
Проще всего взять
extensions.
у
It's
extension,
easier to
который
take
называется
it
Bloom.
from Bloom.
Где?
Where am I?
Так, я все не туда скопировал. Надо
I'm
было
sorry, I
правильно.
copied it in the wrong way. I should have copied it in KDY.
Забираем
So we'll take
заголовочный
the
файл.
header files.
Забираем
We'll take
исходный код.
the initial code. Can I interrupt you for a second? Why gist not from Bloom? Does it have fatal failure for the implementation?
Я просто люблю гестапо,
I like
конечно, его
gstop, that's why I use
На самом
that.
деле в Bloom
In Bloom,
не такая сложная структура,
the structure is not so complicated for us to
допиливать.
put
Но по
something
сути,
additional, but in general,
мне нужно показать, что
I need
делается
to
10
show
минут.
how we can do it in 10 minutes.
Что-то
This is
такое.
why. But for some reason, it's not working. We'll take something from Bloom. We'll take Bloom control, for instance.
Мы из Bloom возьмем
And we'll
SQL,
take
который его
SQL
создает,
from Bloom, which creates it.
и
And
возьмем из него
we'll
makefile.
take makefile from Bloom.
После этого нам надо
Right after
все
that,
накопированные
we
файлы
need all the copied file to set on file. We created this folder. Now we have a separate IDIY 1.0.
тему. Я, к сожалению, не знаю, как это сделать.
Unfortunately, I do not know how to do that, how to make it faster. No microphone. Since we have a video, please, if you have questions, it's better to use the microphone for your questions or remarks.
Bloom меняем, в общем, на
All the
IDIY.
Bloom we changed to IDIY, all the names.
И операторы класса
And the class operator,
блумовские не понадобятся.
we will not need them. The Bloom class operators, we don't need them.
Здесь мы сказали, что мы
Here we have given us the function, which is the index handler. Let's announce it
Вот эту
in
функцию нам
real.
нужно экспортировать.
We need to export this function,
Как она экспортируется? мы
and
уже
it's
посмотрим.
being exported. How we can do that, we need to look up in Bloom. We'll take the handler
И
and
экспортируем.
we'll export it as IDIY handler.
Еще надо в расширении добавить
Then in
элемент
extension we need to
расширения,
add PG module magic,
чтобы оно было нормальным расширением.
so that it has a normal extension. Then control file IDIY,
И заменяем сам
and we change it.
Bloom. Правда, это не signature файл.
This is not signature file basic, this is not true. We'll just take it away, just delete that.
Вроде ничего не забыл.
I think I didn't forget anything, so let's put it all together, let's set up. No, it's not working. Makefile hasn't been fixed. Makefile has been taken from Bloom. We need IDIY.
Список файлов.
So the list of the files, you can take it from the list of the files from gist. Everything is highlighted. The list of compilers files.
Тестов у нас, конечно же, не будет.
We're going not to have tests.
Можно написать?
Well, we can write them,
Это займет больше
but it
времени,
will
чем
take more time than we have.
Кажется, все должно работать.
So everything should be working now. Make install.
Everything's
Everything's running. Okay, let's set it up. Let's have a cluster. Demo DIY. DIY. Let's start it. Demo DIY. Start. System administrators. So I want to bring it back, so it will be like that. There was some server somewhere, but it's not there anymore. Yeah, server started. SQL, Postgres. We forgot an important thing. We could index something, and we need op class. Op class will take simply from cube. I like cube, that's why I take op class from that. Here we have op class. We'll take it, we copy it in DIY, and we say that this is op class operator for cube, which is called IDIY cube. For the methods of indexing IDIY. And we delete compress here. So everything's ready. I need to install, reinstall.
Create extension cube.
We did not break anything in cube, so it's not surprised that it has been created.
Create extension IDIY.
So it says the function IDIY handler has not been exported. We broke something in make file or in controller. We broke something in the controller. I hope this is the last bug that I have. It doesn't happen like that. So let's create a table.
Create table X as select cube random. Например, не cube, у нас будет.
So this one cube from
series.
generate series, and we'll put hundreds messages in there.
Okay. Create index on X using ID.
Create index on X using IDIY for the cube column. Everything's running. The index has been created, so we need to select the star from X. Where cube included into some sort of cube from 1 to. So it is running through xscan. Explain, analyze. Yes, it's through xscan. Set enable. Sexscan. We could put some data into this, but we'll do it later. Express analyze, index on the scan using xcube IDX. And we see that this type in index, which is called IDIY. Now we have a full copy of index, and we can hatch this and make some horrible things in it. Copy it to prod, create this index, and see how it's false, and delete it, and nothing will remain. Now we can make experiments with index somewhere not far from prod, and nothing bad will happen. No index corruption or whatsoever. But this is not true. There is a complex thing that you cannot do online. This is val log, that with extension index you need to rewrite. There is usually a function slog insert, which has to be changed to generic slug insert. So you need to be very careful changing it in order to use different val log system. So it's technically it can be done as the polar RP code, but it's hard to read this during the conference online. And the rest of the presentation is about what you can do in such DIY hacks and indexes. What can you do with B3? It will be more difficult to do it because it has lots of coding that checks the identifiers, but you can bring it to the extension, but you have to work with sigfolds first. In B3 we have binary search page by page. When we use it in index scanner, the page, when we review it, we use classical binary search supporting the mode from range. And we try to find this limit on the page, the high and low. And I talked to Microsoft SQL Server specialists, and they said we had the prefetch in 2002. And I said, okay, we'll do prefetching as well. This is a simple patch, but before calling up for comparison of the keys, we give the instruction to the compilator that it has to put L3 into L3 cache, some possible results, left results and right results. So this is how we put the data twice time bigger, because sometimes the data is missing. There is more of a processor caching. This is the reason why. So I realized I implemented this patch, and with an easy key, this development brings us plus 4% of performance. We haven't done a lot, we just added 4 lines, so I decided to develop it a little bit more. So the way the data is located on the B3 page first. In the beginning of the page, we have massive ID, and it is ordered based on the keys. So in the end of the page, you have some tuples, and all those tuples can be located in a different order. So we can take this tuple and rearrange them in such a way that during some auth and bin search, they have to be in one and the same cache lines. All those tuples that are being reviewed, they have to be in one cache line. This was not my idea. That the idea was a long time ago, before the database. Eitzinger layout, this is called. This is some sort of the tree, which is this is a layout of the tree with the index number 8. We can look up at the key with number 4 or number 12. So we'll take these tuples. And put them on different cache lines. No only three prefetch, but only one. And this will be in this or that tuple. So if it's sorted at 64 bytes. So the scientists made the research, and they say Eitzinger layout is really cool, and you can work with a graph, and I couldn't stop it, and I decided to write 3 ways of implementation of location. So there'll be the link, and you can have a look at the patch if you're interested. During the vacuum, when we actualize the page of the B3, we sort of make different fragments, and we use the different tuples, and the order is different, but the location is in a different place. So the first one is sequential, which doesn't make any sense. We only saw the tuples in IT. B3 strategy is the sorting when we make the binar search from the root of the center of the range, and then amped both layout, which groups 3 elements together. In this case,
вместе должны были бы
we
лежать
put together
4, 2 и 6.
4, 2, and 6
In
in one down and both layout.
При рассмотрении
When looking
элемента
at the
4
element
мы
4,
столкнулись с кэш-миссом.
we have a cache miss.
Элементы 2 и 6 у нас
2
окажутся
and
в той же
6 will be in the
что и
same
элемент
cache
4.
line as the element 4.
Вот, реализовал я
So
Айценгер layout тоже,
implemented
и
Einzelgern
побенчмаркал
layout, and I
тестом
benchmarked with a
bench,
very simple test, which is called dbench. I didn't come up with any
адаптированный
adapted
модель,
testing for the B
и
tree,
сделал их в двух
and
версиях.
I came up with 2 versions, with cache fetch disabled and
Вот тут я
able.
обнаружил, что как и у ученых,
So when I looked at the disabled prefetch, Einzelgern layout gives the 3% to the performance increase, and with
просто не делать ничего.
terminal prefetch, it was not that good. So during the vacuum of the index, it takes the performance as much as it takes from, as it brings for the correct order of the tuples on the page. So I send it to the hackers, and I think 2-3% of the performance is not a critical figure to anyone. So these things you can try and put it on the fast.
As an example, a big change in indices, you can see. We started in 2015. A working patch was proposed, and it was committed only in 2018. And it was done based on SQL standard. And it's very hard to track changes in indexes, but there you can do whatever you want. You do anything and wait for the reply. If you are fed up with it, we just delete and dump your extension. What else can be done with B-tree, for instance? Now our index works over the subsystem of cluster operators. It's a wonderful idea, allowing to being abstract from mechanisms building trees and inverse indexes from the mechanism describing the data themselves. But this abstract layer is not free of charge. Very often we have integer identifier 4-byte based on which we build a B tree. Why don't we make a B tree which can identify only 4-byte columns and put away all cluster operators and leave only the functionality which is the hottest one, the most demanded one. The same index can be done also for text, because the discriminant among tuples there is just a subline of key lines. Some prefixes and suffixes in tuples can be removed, and as a result the search tree can be done much lower. This is just an idea, it's been discussed, I haven't tried to implement it. If we move on, we can try to make right optimized B trees. Normally they are called LSM trees, and in the case with the index with an extension, you can make one small B tree for inserts and one big one where you would merge your data. For that, you would have to copy the B-tree code twice. It's a joke, of course, you have to orchestrate smaller trees somehow, but the idea that it can be an extension seems quite simple. Going forward, it's possible to realize also memory indices, but it will not be possible to make them in a fork type. You will have to write more code. It's not DIY. It seems like full-fledged work with thousands lines of the code. Summing up, I'd like to say that indices not always speed up your base. Very often they slow down records, and self-made indices can just break the base or put them into read-only or give some downtime. Just a second of marketing. You can, on our stand, you can tune our Postgres vanilla without extensions and get a grant for Yandex cloud. That was all from my part. If you have any questions, I'm ready to handle them, please. What did you call cache line? I don't know this term. Cache line is a granularity using which processor puts data into cache. If you apply to one address in the virtual address space, you should check that you should so pass TLB, make the physical display of the address, and when you apply to a physical address, you should make sure that you have 3 levels of cache. You should check that the address is not there, and only in this case you can initiate the data exchange in DRAM, not to do byte by byte those requests. All modern processor architectures work with so-called cache lines. So you go to one address, but all 64 bytes afterwards will be loaded. It is different from the processor. It's 64 byte on this laptop. In some servers you can have 128 byte, but it's an exception. It's not so big difference then. So if you applied to 1 byte from this cache line, the first application initiates the data exchange with the DRAM. The second application will be free of charge. You will have them just in the registers. Difference of nanoseconds only. You mentioned the hard-code operator. Are there any data? How fast would it be? It's just an idea, the idea which may not fly. I haven't tried it. One student of mine, I tell him everything about class operators, we can work with many. He said, how complicated is that? Let's make one comparison operator in the code, and that's all. Cool, we can do it. Okay, I told him, let's do it tomorrow. Well, that's just an idea, you know. The idea of simple optimization, which as a result may not be very simple. If you're ready to invest in it and to investigate it, let's do it. Maybe I can help you with the code. If you will have more questions, you should come to our stand, Yandex. Let's now go to those who wanted to listen more about backups, or let's wait for more questions maybe. Okay, no questions? For what operations have you realized your indices? Or have you ever realized it, at all? These are just developments to experiment with the code. Maybe it will work out, but so far, well, in CommentFest I have 4 patches about gists, which do something better in the place of just gist. I gathered it all together in a separate fork, and in this fork I would like to make improvements post-gist. Post-gist community have lots of requests what they want to do to see in gist, but so far I was too busy to do it in a proper way as they like. Dorothy sits there and knows. He has lots of ideas how it should all work, and maybe sooner or later I will have time to implement these ideas in the form of as extension index. What are the limitations will be there to use index as extension, or if you commit it directly to Postgres core? apart from it, that it would be long, well, about the methods of access, are there any limitations of working with it? Not limitations, not quite. Well, generic wall works worse than a specialized wall. When you write a false tolerance extension, you shouldn't create a wall record. You should not describe which bytes should be taken. You just give to the wall the page and tell him find 3 differences. It scans all bytes, finds out what changed, and records into the wall. It's convenient from the programming point of view. You shouldn't think a lot. When you replace wall in if-fork index, you normally delete the code. But this comparison would take time. As far as I know, Alexander Korotkov wrote some optimizations for this comparison process to understand what changes were made on the page. But to simplify generic file patch, well, these changes were not implemented. Now the situation with generic wall is the following. There are not so many indices as extension, and it might be improved if many people were using it. I know the only index which they use better, it's a RAM, full text search, which not many people need. Many can go with Gene, with Sphinx, or others. If people make more fork indices, there will be more demand to make generic wall closer to the specific wall. And then they would work in the same way as embedded indices, no other limitations which I would know about. You wanted to continue with something about backups. Several people approached me and told me that yesterday they couldn't come. Let us gather not for the record. How many people would like to listen about backups? That was the yesterday's presentation. If you heard it yesterday, well, then let's discuss it. And we spent a lot of time on backup, and it's possible to find 4 presentations of mine in the internet about wall G evolution, and you can find also presentations from my colleagues from Yandex Mail on the topic of backupping using other systems, how they selected it. And this presentation is more about the basics, how quickly set up backup, and about new features which we want to add to the backup system. First, you have the cluster. You want to make backups there. How can it be done using our wall G system? You come to our stand, take a promo code for Yandex Cloud, and there is an object storage, S3 compatible object storage. And of course you can use Google storage in the same way, or Amazon storage, or Ceph, although there could be some problems with Ceph. We can discuss it later if you're interested in. You create a bucket, you create a service account, and you create an access key. That's all what you have to do. Then you download our release version from GitHub. And what is the difference between release versions and pre-release versions of WallG? The workflow looks as follows. We publish a release, we wait for some time. If no bugs are found, we mark it as a full-fledged release. It happens not often because the community finds many problems. For example, the current pre-release contains a well-known bug about that the backups of previous WAL-E system are not restored, although this feature is supported. It works in release okay, but it doesn't work okay in pre-release. After you downloaded WAL-G binary, it's only one exec file. You can install a variable environment which is used to manage WAL-G. Now we have the indication what storage we use. We use Yandex Cloud storage, the access information, access key, secret access key, and the place where to store it. I would recommend to you to store it in a separate folder or a separate bucket, because during the major upgrade, timeline is being reset, and the linear character is not in line with the lexicographic order of WAL. WAL starts again from 001 timeline. On this slide, we executed backup list command, which returned us all backups we have. Afterwards, we can execute backup push by indicating to WAL-G where is the location of our cluster. If the database is not configured for the point-in-time recovery, WAL-G will return a warning saying that the archive mode is not that we expected. And in this case, the copy is of no use. We should understand how online backup works in Postgres. We inform cluster that it is in the backup mode. Afterwards, we grab all files, whatever we want, we place them in a safe location, and this set of files is not a consistent copy of the cluster. In order to get another normal backup, we need the whole log of the write ahead for the whole period of the backup. Every backup has a consistency point, the minimum logical time for which this cluster can be restored, given the total WAL. The system told us that we do not have enough archive mode. We go to pre-config, archive mode on, archive command executed. This is another command of WAL-G, which Postgres returns when it wants to archive another segment. Here we import all variable environments with secret keys and call for WAL-G, WAL-push, and the percentage Postgres will automatically be replaced with the location of our WAL file. How do we operate WAL-G in Yandex? Normally we make a high availability cluster, which means that we have a master with the attached at least one synchronous replica and a few asynchronous replicas. We constantly archive the write-ahead log in the Yandex object storage, and we take a backup from the asynchronous replica normally during the night. At the certain point of time, all keepers are gathered and start to vote. If there is an asynchronous replica in our cluster, the maximum LSM replica wins and makes the backup. If there is no asynchronous but synchronous, we take synchronous replica, make a backup, and if there's only one master in our cluster, so it takes a backup. But we will say that it doesn't happen that there are two masters in a cluster, but everyone understands that that would be a critical situation for Postgres. When point-in-time recovery, we normally create a new cluster, which we have to restore as fast as possible for the maximum basic copy. And so before the necessary time period, we should also roll over the log. This is the point of dichotomy. We understand that there is one stream of journal. These are consecutive changes which needs to be implemented on the cluster. At the same time, we can make rare backups, and in this case we will have to roll over a lot of journal. If we do it frequently, so the restored will go faster, but it would slow down our cluster. It would load resources. Many of our databases also are loaded in the night. People send letters also during the night, and mail has some loads during the night too. We would like to avoid loading from backup and don't store a lot of data, because using network for the transmission of backup and using disks of the object storage. Also very often we solve the task of high availability cluster, because the cluster doesn't take the load. By being upgraded to maximum flavor, service operators try to add a new node for the reading, new leg for the load, but the adding of new node should be as fast as possible to be able to react with it to the growing load, and it should not create additional load for the master. We should come as close as possible and to take streaming of the last piece of the wall from the master. Very often we need to repopulate the meteors. The master which is in the network isolation, we consider it as dead. He made some service operations and then went to the future story. We tried to rewind it, but rewind doesn't always work, because it can go quite far and it won't be enough, the wall, and so we repopulate it. This operation happens quite often on our scopes, on our volumes, and we try to optimize our backup systems for this situation. Everything in total resulted in the list of things we would like to have in our backup system, and we lack compression here, and this cluster data can be compressed many times. We also lack parallelism in the base backup, because very often we work with powerful hosts, the capacity of which is measured in the number of cores. But if we have a consecutive copying system, all these cores are not needed, they just heat up air. So we would like to use parallelism in all operations, since very often we have not our data, we need encryption. When we send it to object storage, we need throttling of resources, not to kill master by our parallelism. We read in parallel, but someone would like to write to the database. So we shouldn't use up not more than 1/2 of the throughput of the disk for reading. And of course, backup management we need. Our backup management is quite simple. We have to support the window of the latest 7 days and be able to restore at any point within these 7 days. We tried and considered many different backup systems. They are all wonderful and interesting, but as I mentioned just recently, the features matrix of all backup systems has a big range. It's not eradicated. Every backup system has own unique feature which no one else has, but the selection is quite complicated, and there's always something missing in the box. We develop WallG open source project where also Yandex developers are working, myself and Volodya Leskov. The ideology which we want to stick, it's quite simple. We want to make our instrument as simple as a balalaika. I couldn't find balalaika, it's ukulele on this picture. And we have 4 main teams which we would like to optimize by performance. Sending of val push, taking a segment in the recovery command, using val fetch, sending a backup, complete backup to the object storage, and receiving it from the object storage. Of course, there are other commands, other features. First of all, these are being optimized. One of the features which we had to realize in WolG is the existence of so-called delta copies. This is a way to get a balance between the speed of restoration and the volume of stored and transmitted backup. Delta copy is practically a copy containing only the files which has been changed from the last full backup. And it also contains not all blocks in the changed file, but only changed blocks. What is the difference between delta copy and point in time recovery using write-ahead log? The delta copy can be written ahead in parallel. It just contains the list of changed pages, and in a few streams we can update different files. The first technology which was created, so-called LSN-based deltas, and the point of this delta backup is that we read the whole cluster, we read all changed tags of file systems, we find changed blocks, and using the block header parsing, we can find it and we can compare it with the LSN of the beginning of the previous backup. If the LSN page is bigger, which means we should place it in the delta copy. Now a few words about parallelism. As you know, the Postgres interface with archive is working with archive is consecutive. Postgres calls the restore command one after another. As soon as it reaches the next one, it receives a file. If you call fetch command from WolG, it would give us a file, and it will also go and prefetch 8 next files. Maybe you would need it. Almost always you should go on, and it allows to restore, to make the consecutive restoration a parallel one. Because when Postgres will ask for the next file, we will tell it's already on the disk, you can get it. We moved on and made the parallel archiving. When Postgres tells us, this is the ready-made WOL file, please place it to the archive. We open the connection, we start to transfer it to the archive. In parallel, we look at archive status where there are other ready archive files out there. If there are some, we grab them and take them. So in this way we paralleled our archiving. It would be critical only for clusters with very active WOL write from clusters which are very much loaded in writing. More than a half of clusters can go with consecutive archiving, and that's all. Continuous night read of clusters was also our worry, and since we read our WOLs, we decided to take some information from there. When Postgres told WolG, please bring away this WOL, what do we start to do? First, we start compressing it, then we encrypt them, GPG, and send them to the network. We do not create any temporary files, we just send it in the form of a stream with small buffers in the memory. But we also edit parsing. We do not only compress it, but also analyze WOL records and see which blocks were changed by these WOL records. For a range of WOL files, we create so-called delta file. The delta file is a list of blocks which were changed in the cluster in this unity of segments. And we integrated close to our WOL. And we had a problem that we are parsing in parallel, and there could be a situation when we start to parse the file from the future for which we hadn't parsed the past one yet. And we have an end of the record, we don't understand where does it belong to. For that, we support data partial files close to the cluster where we collect all these fetches, all these pieces, and all these pieces should be then add up to a full-fledged record. If at least one record is not clear for us, we believe that the story of changes is not known for us for the cluster, and to make delta backup we need to read the whole cluster from the beginning once again, all the data in the cluster. The result is the open source library written on Go for wall passing. In order to understand which blocks were changed, you can use it, and this this is a complicated loop. Our master archives wall files, it archives delta files, which are the change map of blocks. When we make backup for replicas, it takes big pieces from the archive in the form of delta files. Some pieces are not fitting into the delta file, it takes this as walls. Additionally parses them and then builds up the map of cluster and makes the reserved copy of this is the real load of the cluster in the night with LSN based delta, and we see our cluster was read from 3 to 5 a.m. Wall delta happened from 3 a.m. approximately within 20 minutes. We didn't stop here too. We read in the internet about a wonderful Postgres extension as PG prefolder, and rollover very often breaks, very often is slow during reading. In this case, we need to change something in the block which is on our disk. We have to start a synchronous operation of read, and our SSD disk controller will not be loaded. It will not have the reading queue. So PG prefolder and wall G scan wall a little bit to the future from the point which is rewritten, and start to warm up all these pages in page edge, which will be needed soon in parallel in order to finish the write ahead, not in the disk but in the processor. Our goal was the processor, not the disk. That's what we have in pre-releases. What else we want to implement? We see that delta copy for the whole day has become quite cheap. If we make it for a shorter period of time, it will be even more cheaper. And so backups could be done every minute. If it's almost free of charge, why don't we do it? What would this give us? In this case, we can, let's say we have a full copy for Saturday, we have a delta copy for Monday, Tuesday, and Wednesday, and Thursday, and in the middle of the day we had a fail. At 12 o'clock we dropped the base. It happens sometimes completely. We killed all hosts, we need to restore everything. So we have to write ahead 12 hours of wall. And if we would do delta backups every several minutes, it's just an idea. So we will be able to come closer to the place where we want to have our point in time, and just write a smaller piece in the consecutive wall. Some optimization is possible. If we see a block which will be changed on Wednesday, we shouldn't write it on Monday. Many operations which are far away in the past can be just skipped because their result will be anyway rewritten by another backup. This technology is realized on the file level. If some file will be deleted on Wednesday, Monday, Tuesday will not be rewritten because it will be deleted anyway. We would like to bring it to the block level. And so far the code is too complicated, and the output is at the level of here is speaking difference. The difference very, very tiny. But it's interesting. Another unexpected feature which we would like to have, we would like to make WAL-G be able to manage MySQL. But there is no subsystem of archives to restore command. So we have to take the cron, which would scan bin logs in the file system. And so far it happens not very good, but we're working on that. We would like to make a scalability for WorldG to be able to bring a block for backuping a big amount of clusters. When WorldG doesn't suit you, if you have no synchronous replica, the archiving system doesn't guarantee you every byte. It means that database is not the database. You either have a backup system which would support synchronous replication, or you have physical synchronous replica, which in case of network partitioning would keep your latest committed transactions. Now WorldG doesn't work with WorldE. WorldE is much more settled solution written on Python, works much slower, but the community is much wider. Since they both use parallel archiving, WorldE starts to steal files from WorldG. So the common work of these two systems so far is not possible. We do not have embedded verification. We don't have an opportunity to store certain backup for the past. And we cannot work with the point-in-time backup recovery, and we do not have the checking of control sums while reading control pages. Someone would need this feature. All these features are brought to Google Summer of Code product. If you have good students which want to earn some money and write something and do something good for the databases, they come to our Postgres, and we have a list of projects for them, and project with WorldG is there. We have many smaller issues we should like to see in the pool of requests. For instance, if you check this empty folder, show the empty folder, it would fall. It will hang. Well, we would like to handle this and provide a message from the operator. Now the system sees just a stack trace with not always readable names of functions. WorldG now is not able to make offline backup. If your database is hanging, it's not possible to connect to it, doesn't know how to call the backup because they have in the names a part of LSN. It'd like to be able to make a copy of a hanging database. We have badly handling of the situation when the bucket doesn't have splice anymore. WorldG will try to place it in backup, retrying, despite the object storage tells there's no space, but WorldG will keep trying because already started, maybe we will have some place. It happens very long. We would like to see a pull request which would improve WorldG in this place. And the node functionality is covered by integrational tests. We would like to test it all in Travis, commit by commit. So far we test only standard write ahead, and we'd like to make it for all Postgres. WorldG means more thousands of clusters, more than many thousands clusters, many terabytes of data, and hundreds of to-do items we would like to see in the pull requests. If in the evening you think what you'd like to write, not C89, you don't want to write index, write WorldG, we have tasks for you. So I'm finished now, that's fine for me.
Если Юрий Жуковец, наверное, есть в зале, это вы, да? Ну, тогда можете подключаться потихоньку, а в это время можно задавать вопросы, наверное.
As for the questions, let's do it separately, maybe